Hello, good morning. So this is going to be lecture 3 for ARCG 325 of the housing course that is named Special Organization of the Dwelling. As I explained to you in the first lectures, the course is divided into three main parts. That is, the first part is more theoretical, that was 1 and 2, and now in lecture 3, 4, and 5, we are going to pass to a more hands-on approach to how to design a residential building. And we will start today, lecture 3, with the dwelling. And then lecture 4 will be about assembling the residential building, and lecture 5 for only the ground floor and the composition of the facade. So this particular lecture will focus on the special organization of the dwelling and is specifically the relationship to activity and place, width, depth, and height, and their importance in the configuration of the dwelling space, and how to combine them in terms of horizontal and vertical distribution. So the first part will be based on the general considerations for partitions options that is mainly guided by the size, the orientation, and the facade surface that we have available to design a dwelling. And then part 2, how each individual dwelling then is organized based on activity modules. And then we have the single space, and then spaces that can be organized in depth and in width. After that, we also have to decide when we are designing modules are going to be organized around the core or around the central space, and the influence of height, meaning double heights and triple heights, in the separation of modules. So going back to part 1, three main factors have a defining impact in the partition options that we have for dwelling. That is the size, the orientation, and the total facade surface. The total facade surface, as I guess you can understand, is how much space of window do we have. Unlike any other building, the amount of window surface that is available for a dwelling determines how much we can do with it, because most of the spaces in a house need to have natural light and ventilation. When it comes to size, the size of the dwelling determines the number of separate spaces that can be created inside it. So for obvious reasons, if we have 10 square meters to work with, most likely we will have one single space, or maybe two. If we have 50 square meters, 100 or 200, then we can insert more spaces within that area. The way to determine how size affects the design of the dwelling is actually the most subjective and relative one, because in general we can say that apartments must be functional and well organized and have enough space to meet the needs of the occupants, but the needs of the occupants, or the consideration of how much space, varies from society to society and within different cultures. And so, as you can see on the image on the side, a 3-bedroom apartment in different parts of the world can vary between 30 square meters and 200 square meters. So it's very difficult to say what is a proper size, besides the fact that they should be well sized enough to assure flexibility, adaptability by the occupants, and above all, it should fill in the needs that each person or group of people will consider to be the minimum requirements. Now, when it comes to orientation, apartments can have three types of orientations: single-oriented, a double-oriented 90 degrees, and double-oriented open-ended. The orientation of the dwelling determines basically where is the natural light and ventilation going to come from. And as I explained before, it's important because most of the spaces within a house need to have natural light and ventilation. So a single-oriented unit normally, as you can see on the left, has a more rectangular shape and a wider facade surface because there is only one source of window or natural light. That means that most of the space most likely will be oriented towards that area, and the backside of the unit can only be occupied by areas dedicated for services like toilets, storages, and sometimes kitchens, but it's not the best condition possible. Double-oriented units tend to have a more squarish shape because they have a facade exposure on two sides. That's why it's called 90 degrees. They are very good to create more centralized plans because of their shape, but the rules that apply to the previous one are the same. That is, um, living spaces are located on the window surfaces, and then technical areas and storage areas are located on the walls that don't have access to natural light. Double-oriented units, open-ended, are very common in residential design because they allow for optimization of facade surface. As you can see, they are able to be as rectangular as the single-oriented units, but with half of the facade surface. And they also allow for natural ventilation, or not natural ventilation, sorry, cross ventilation from one facade to the back. They also allow for a easier separation of functional zones. Normally, the entrance is in the center, and service areas and storage areas are located in the central area. And then from one side, we will have the most public areas of the dwelling, like living rooms, dining rooms, working areas, and then on the back, you have such as bedrooms. So it allows for not only an easier distribution of functions, but also a cross ventilation, which is a plus. Now we will just go through some examples for you to have an idea of what we are talking about. So as I explained, single-oriented units, the main advantage is they allow for any type of access to the units. So in terms of the assembly of the building, they are extremely flexible. The downside to it is that the back part of the house, this for example is the mountain dwellings in Copenhagen by Bjarke Ingels Group. As you can see, the back part of the dwelling has basically toilets, two toilets, and a kitchen, and the entrance hall, right? And then the part that is exposed to the facade, it has the bedrooms, the living, and the dining, and a working area that is on that spot. Notice how the facade is not straight, but does this kind of L shape. This is this is a technique that architects normally use to what we call double the facade surface. So if the facade surface was here, we would just have this pane and this pane. But by creating an L shape, we double literally the area of the facade. This is something that architects do in single-oriented units to reduce the circulation space within the dwelling unit, or optimizing the area that is needed to be used while still doubling the facade surface. Now for a double-oriented unit, 90 degrees, this is an example of Ansa Viertel housing by Alvar Aalto in Berlin. As you can see, it has a much more squarish shape. Normally, these dwelling units are also optimize a lot of the circulation space needed inside the dwelling, and they are normally space-centered, meaning all the spaces are organized around the main central space, that in this case is the living room. And then, as the previous unit, the kitchen and the toilets occupy the walls that don't have access to natural light, but an advantage regarding or relating to the previous one is that, as you can see, the kitchen is able to have natural light and ventilation, while the other one was not possible. As a note, Single-oriented units rarely can have a higher depth than 8 meters. So they normally have a depth of 8 meters, and then the width can vary, can be 10, 15, 20. A double-oriented unit, 90 degrees, has an average size of 10 by 10, and then normally increases as a square shape. Double-oriented units, open-ended, have an average depth of 14 meters. What does this mean? That means that when you are assembling the building, the depth of the dwelling units that compose the building will give you what we call a fatter or thinner building. Thin buildings normally don't look very proportional, especially when we have several stories going up and then the width, so they tend to look like little worms that are very thin. And so when we don't want this to happen, when we want a more balanced building in terms of proportion, then we need to use units that are wider or have a higher depth so that the building becomes more proportional. And that's why it is important. So double-oriented, open-ended units, as I explained previous, this is Immeuble Clarté by Corbusier. You can see you have the service areas in the center alongside with the entrance. So the service areas, the toilets and storage are in the center, and then you have bedrooms to one side and the living room and the kitchen to the other side. As the double-oriented unit, 90 degrees, the kitchen is able to have natural light and ventilation, while the single-oriented, most of the times, they cannot have, because it's impossible. Now, regarding part 3, that is the total facade surface, the way it affects the design of the dwelling is basically related to the quantity of natural light that can enter the dwelling. Like I was explaining the single-oriented unit, if I have an L-shaped facade instead of a facade, I double the amount of light. If I have a double height facade instead of a single height facade, I double the height of natural light. So facade surface, we cannot see facades as straight planes. They can be manipulated into terraces, recesses, to maximize the facade area that we need. And for example, this is an example of a recess. So for example, in this building by Kordak in Madrid, if you look at the building is extremely enclosed. Because it's in an area that is very noisy, a very dense urban fabric, so the architect wanted to create or to give a sense of privacy to the flats. But he also needed, because of the size of the plot, he needed to have very deep dwellings. But the problem of the deep dwellings, especially when they just have one facade surface, is that you cannot go above 14 meters. So the way the architect managed to deal with this is to create these recesses in the facade that are like terraces that you can see here on the plan, that basically push the facade surface around 10 meters inside. So then he managed to have units that are over 20 meters deep, when in a normal rectangular unit it was not possible. That is what we mean by manipulating the facade surface. Facade surface area, as we call it. Next slide. Another possibility that is the most common one, that is the dwelling is just made wider. So you know that the services areas can be on the back of the dwelling, and because they don't need natural light and they can have mechanical ventilation, and then you need to put the living areas or the living spaces where the surface is. So you just add facade surface according to the number of spaces that you need. The problem, as you can see here in the Rue de Suisse apartment by Herzog de Maron, is that normally the buildings will start to become very long and narrow, which many times is not a nice form or a nice proportion to have in a building, but it ensures that the dwelling, all the spaces within the dwelling, have the proper conditions. What is not acceptable in any means is that we have bedrooms or living areas without natural access to natural light and ventilation. Another technique that we can use is to make the facade taller. This is Unité d'Habitation by Le Corbusier, and this building, this dwelling unit is around 19 meters deep. And similar to Kordek building, but the building can only be so deep because the architect created these duplex apartments that have this mezzanine level. So normally, for you to have an idea, the light enters the interior of a flat in a normal height around 4 meters. So if you duplicate the height of the flat, this will become around 8 meters. It's not a direct proportion, but it's more or less. So by creating these duplex areas, the architect was able to extend the depth of the dwelling because the light can access a wider area in the interior. And then the rest of the organization is similar to any dwelling that is double oriented, that is the services are on the middle and the living areas are on the edges next to the natural light. So this is the information regarding the part 1, that is how size, orientation, and facade surface affect the dwelling design. Now we are going to talk about how activities, and I'm already kind of talking about it, so I say that living spaces are on the facade, technical spaces are on the back. This is normally in a dwelling what we call activity models. When we think about any house or any residential apartment, we know there are certain activities that take place, like sleeping, eating, living, cooking, or living or gathering, cooking, and so on, bathing, and so on. Can have working. This is what Alexander Klein named as activity modules. And we know that those activities might be more or less private. They can require more or less exposure or connectivity to the outside world, and they might be more. And normally the way we organize those activities is we have modules, literally, because all spaces in a residential building have kind of standard dimensions, bedrooms, living areas, and so on. And then we place them close to each other in depth and width. And by doing that, then we end up with an apartment or a dwelling unit, put it like that. So now in the part 2, what I'm going to talk about is how the way we place activity models in depth and width gives origin to a certain type of design. As I explained to you students, creativity in residential design doesn't come from us ignoring these basic procedures, because the procedures don't change. What change is our ability to manipulate them and be creative in the way we manipulate it, not by assuming that we cannot or we don't have to follow them. That is not creativity, that is naiveness. And I have seen many cases where the students ignore these basic standard rules, and then what happens is in the end you cannot design a dwelling, because instead of using this information, or what I call the modularity of residential design to your advantage, what you do is you ignore it, and then it's almost like starting from scratch, as if nothing had been invented before, and normally it doesn't turn out. So it's important that we understand that this is not a constraint, but rather a set of rules and modules that exist to kind of save us time, that then we can work from it and not before it. So now we are going to talk about how activity models can be placed. And of course, we have to start with what we call the single space dwelling. The single space is when you have a residential unit that is basically made of one activity module. It's like having a hotel room, basically, or those small service apartments that include the kitchenette. This is the Nagajin Capsule Tower in Japan by Kurokawa. It's a very famous single-space dwelling. It was made for single workers that would work in Tokyo and didn't want to commute all day. So it was made as a kind of a temporary residential unit. And it's composed of one single space that includes a sleeping area, a living area, a toilet, a kitchenette, and like I'll give the example of a hotel room. And it has the dimensions of 4 by 2.5. It's considered the minimum area for a living space. Normally spaces are bigger than that, but it's for us to have an idea of how the standard dimensions work. And then we can go through some examples of how this was assembled and how does it look like. I will not go through it now because it's not important for, I just like to share with you projects to kind of boost imagination. So now let's imagine that activity zones, the single space dwelling, now we need to add more spaces to it, and we are going to do it in depth. So basically, if we do this, if we add activity models in depth, what this means is that we are going to save facade surface. The depth of an apartment building can significantly determine its ability to ensure natural daylight and ventilation. So normally, the depth is generally determined by the preferred choice of apartment typology. I was saying, what is the form and type of communal access that you want to have in your building? The type of stacking, how the dwellings units are going to be stacked horizontally and vertically, and the overall plot that you have available for you. So, of course, if you have a very rectangular plot, maybe you can have a wider building, but if you don't have a very rectangular plot, then it constrains your design. In any cases, the selected depth must ensure that the building provides a reasonable level of daylight and natural ventilation to the occupants. The building depth is appropriate for the type of apartment, and overall it's not going to create an excessive amount of extra work when dealing with the land and the plot and the site, let's put it this way. It's very important, this note is very important. If you have a single oriented, but it's important that you understand because this deals with depth immediately. In single-oriented units, you cannot have more than 8 meters in depth. Maybe you can extend to 9, 10, but let's say that 8 meters is this average dimension. It is possible, depending on the designs, to have more, but this serves as a reference. In double-oriented, open-ended units, you can have up to 14 meters. Again, for example, Le Corbusier has, Unité d'Habitation has 19 meters, but that's because he uses duplexes. So this dimensions is for you to have an idea of what time, when you are designing a building, because normally we start with the site and the building form, you know that this is the dimension that your building is going to have in terms of depth. If you want more, then you have to find immediately a solution to deal with these issues of natural light and ventilation. Many times the students do, because when in other designs what happens is the other way around. We develop the form and then we put the spaces inside. In residential design, no. We have to decide what is the type of circulation, what is the type of stacking, and what is the type of dwelling unit, because that is going to determine how the building form is going to turn out. So if we don't decide that ahead, then what happens is we do a form and then we cannot fit everything inside, and you don't want that to happen because it's a nightmare. So two-zone deep apartments, that is basically if we grab a single space and then we add one on its back. They are normally used for very small apartments, and like I explained to you in the example of the single-oriented unit, if it's single-oriented, normally the kitchen and the toilets will be on top, as you can see here in this Alvar Aalto building, and then the living areas will be on the front. If it's a double-oriented unit, then you can have the services in the middle. But in two zones deep apartment, that rarely happens, because two zones means that you have a living area and then a service area. So most of the times, this type of organization is used for very small apartments like studios in single-oriented dwellings, like in this case. In three-zone deep apartments with normally what happens is you start having the creation of zones with the central zone will be for technical areas, and then the ones on the tops will be one for a more private area like sleeping activities, and the other one for living activities. The maximum depth of a dwelling with 3 zones deep is 10 meters. When you have a double orientation, a double orient unit, you can have up to 14, but you have to be very careful if you are using single oriented units to not ever use more than 10 meters, because that means that you will have 2 zones next to the facade that will be stacked together, and you will have to find a way to bring natural light to it, and then the third zone that is on the back is the one that is going to have the services. Which is a complicated task to achieve. For example, in this case, the way it was dealt with was through the creation of this kind of courtyard in the middle. So we have a sleeping zone, and then in the middle zone we have the toilet and the access to the building, the entrance hall, and then we have a third zone that has the living areas, and then connected to a courtyard. So it is kind of a single-oriented unit because there is only one facade available, but because of the courtyard, it creates the opportunity of acting almost as if it was a double-oriented, open-ended unit. So if it's a double-oriented unit, open-ended, 3 zones, it's a normal setting where the zone in the middle is going to have the areas that don't need natural light. If it's a single-oriented unit, then normally the way we manipulate spaces in depth is by creating voids that allow for the natural light and ventilation to enter the building. In 4 or more zones deep, the system is exactly the same as the 3 zones, 1 single within the building to make sure that the natural light and ventilation enters the spaces. This is the Funen block in Amsterdam. That is a very massive built-in block, and the way the architects managed to deal with it, as you can see in the form development, it was to deal with the depth of the building was by creating these voids that allow for all the living spaces of each unit to have natural light and ventilation. And we can see an example here. For example, this unit, the units on the corners, on the edges, are the ones that are going to have more depth. So as you can see, what happens in the units on the top, on the edges, is that they are very long and narrow, but then on the upper floors, they will have these voids that will allow the natural ventilation to the spaces. Let's see, for example, here, this is the ground floor plan. So you have the entrance with toilet, kitchen, living area, and the staircase. And then when you go to the upper floor, you arrive through the staircase and you have a bedroom with natural light, and then toilet, and then a bedroom, a courtyard, a bedroom. And now these 2 bedrooms can share this kind of courtyards that allow the natural light to enter the building. And here are some images for you to see how the courtyards work within the space and so on. So this allows for you to have very deep well. For example, see the shape of the Funen block. It's a very squarish shape, so it allows you to have a very squarish building with a maximum optimization of facade surface, as you can see here, but yet because of the creation of the voids, you still have a dwelling that has all the necessary conditions of natural light. Another example for even higher depth in single zone width is Chermaev's Patio Housing from 1963. It's a very interesting module of how you can create a modular intertwine of space and void to make sure that all the areas of the house have proper ventilation. However, a note must be made. Whenever you start adding activity modules in depth, what happens is not only you create very long corridors, which sometimes people find extremely annoying, or if you cannot create corridors, you will have to pass from one activity space to another, which again, in some cultures and for some people, are considered to be extremely annoying. On the other hand, like Chermayev said, they allow for almost this introverted appearance to residential, not appearance, introverted feel to residential design that for some cultures is actually quite appealing. So again, the way you decide the depth and the width, how you place the depth of the width and of the activity models is also related to the type of building that you, the final form that you want to have, but also to what you want to achieve in the design in terms of the people that you are serving. It's not just a creative decision, let's put it this way, but it's much more a pragmatic decision where you study the, the kind of the target that the target market that you are trying to achieve and what would be a solution that is more suitable or that you believe it's more suitable for them. And then after selecting that, then you start using your creativity to do a better solution, or that what you consider that exists until now. Now, when this was related to the depth of when we place activity zones in depth, now we are going to see what happens when not only we place them in depth, but also in width. That is what happens with most dwellings. So if the dwelling is made wider, what happens is the facade surface will increase. So until now, we were making the maximum optimization of the facade surface. Once we start adding activity zones in width, the facade surface will have to increase. This can be done by adding in width or by adding in height. So new spaces can be added as long as there is a place to add it. So it's like creating literally an addition of zones. The problem is the limits are the building. Obviously, in case of double-oriented units, open-ended, the preference is to use both facades as much as possible. There is no sense to have a double-oriented units where you don't use the open-end facade because they allow for cross ventilation. And normally, when we start adding in width, facilities are positioned along the boundary walls between those units for technical issues, facilitating technical issues like shafts, but also for optimization of construction. So when we have one zone deep and two zones wide, we, like the previous situation where we just have two zones deep, what this only happens in very small dwelling units like studios, because if I have two zones wide, what happened most likely is that you will always have to cross one zone to go to the other and vice versa. So it works well if it is like two spaces where you have like a living space and then a technical area with toilets and kitchens. If you start adding zones in width in an apartment that only has one zone deep, what will happen is for you to go to a third space, you have to cross the technical area, which is not the best solution to have in a dwelling. Like you can see here in this residential building by Ritvo. Then when we have two zones deep, or in the moment we having a combination of depth and width is when units start to become more flexible and offer more variations in terms of design. Because, for example, as you can see here in the Batavia residential building in Amsterdam, we have basically 4 zones, 4 activity model zones that are 2 zones deep and 2 zones wide. And this way you can easily organize, it's a single oriented unit. So you can easily organize on the back all the service areas, and then on the front, 1 activity zones for living quarters and the other for sleeping quarters. The space of corridor is not very wide, so and it can have a quite squarish shape, meaning it will not be too long. And see, as you can see, the form of the residential building in the end, it's wider and narrow, but not in a bad proportion, or a proportion that it's too extreme, which is a good thing. As a note, whenever you are creating activity zones where you have to combine areas, normally we use balconies, or extensions, or recessions to accommodate spaces or activity models that have different areas. This is what happens here between the living room and the sleeping spaces, because sleeping spaces are smaller. So to keep the modularity of the building but still not have spaces that are too big or too small, we use recesses or extensions to achieve that purpose. Just as a note, the dimension of this flat, or normally this type of flats normally range between 8 to 9 meters deep and 10 to 12 meters wide, just for you to have an idea. Then you can have 2 zones deep and 2 zones wide, but with double orientation. The good thing about it, and we can see it here in the Weissenhof apartments by Mies van der Hoe, the good thing about it is that you are more flexible in terms of the placement of living functions, and you are allowed to separate the living areas from the sleeping areas. Because here, for example, you have living area, bedrooms, and then toilets and kitchen. So these 4 zones in total, all of them can have natural light and ventilation because you have a double orientation unit. When we move to 3 zones deep, 2 zones wide, that's when you really centralize the technical area. So before we had 4 zones, all with natural light and ventilation. Now what's going to happen if I go in deep and I enlarge in depth, not in width, what will happen is the technical areas will occupy the central zone that doesn't have natural light and ventilation. So like we can see here, bedrooms, living areas occupy the facade surface, and then kitchens and bathrooms occupy the central areas. If we start enlarging in width and not in depth, what happens is this. This is, I think, the best example of the type of form that comes out of a building that has 1 zone deep and 1, 2, 3, 4, 5 zones wide. It is the Kitagata apartments by Sana. They are extremely flexible, they are extremely well ventilated and lit, but they have this very long and tortuous shape with very long corridors. Again, the way we choose which type of flat we want to have, it's literally related with how important some factors are. Or what is the weight that we put in the different parameters of residential design. So if for you natural light and ventilation is the most important one, then probably you will choose something like this. If it's more about optimizing facade surface, then you definitely will not do this one, because this waste uses a lot of facade surface. So it really depends on the requirements of the project. But the characteristic of this type of design is it has an optimum access to natural light and ventilation. It's quite flexible, because basically the skeleton of this type of building is that you have a corridor where all spaces are distributed. So it's very clear and quite flexible in terms of design, but it will always have the consequence of having a considerable amount of space wasted in circulation spaces. Now, when we have 2 zones deep and 3 zones wide, this is probably the most typical configuration of residential units, especially if they are double-oriented, open-ended. So here I put an example of double-oriented, single-oriented, so for you to have an idea. They, for example, here, as you can see, what happens? For me to be able to have 3 zones wide and 2 zones deep, I have to create voids to have natural light and ventilation to the kitchen area. Of course, in most regulations, the kitchens, most countries' kitchens don't have to have natural ventilation. So if it's allowed by the governmental regulation, then it would be fine. In this case, we can see the two situations. Here, both toilets and all kitchens and all living spaces have natural light and ventilation because of the creation of this kind of courtyard design. But then on the upper floors, as you can see, it's long and narrow, and all the kitchens and toilets are located in the back. On the back zone, the front zone is occupied by the living spaces, and they are literally placed alongside the facade. It's an advantage in comparison to the previous example, because in the previous example, kitchens, toilets, and living spaces had to be placed alongside the facade, which would create a much longer facade surface. Then the optimum situation in organizing activity models is when we have 3 zones deep and 3 zones wide, because in that sense what will happen is you will place all the service areas in the central model that doesn't have natural light and ventilation, and then you will literally separate the spaces between back and front, what we normally call back and front, being that front is living spaces, workspaces, kitchens, and back is bedrooms. In the center, you only have storage and toilets, and this creates what we normally consider to be the perfect solution for a residential design. But it's an optimum solution, but that doesn't mean that all of them have to be like that, even because many times the constraints of the project don't allow it to be. The specific requirements of the design don't point out to other priorities. Now we are going to move towards the dwelling, how the dwelling is centered. This is important because activity models have a certain sequence in terms of their organization, and it's very important for you to decide from the beginning if you are going to have a core or space-centered dwelling. It's quite simple. A core-centered dwelling is a dwelling where you move around the central space. Normally, this central space is occupied by technical services. The advantage of it is they are centralized, it's easier to locate shafts, it's easy to make sure that these technical areas like kitchen, toilets are easily accessible from any part of the dwelling, but it means that you have a kind of a loop system, that is, you move around. Then you can have the option of crossing from activity space to activity space, like we can see in this example, Dapperbert in Amsterdam. It's highly flexible because you have sliding partitions that enclose or open areas, or you have a space center that is like the previous example that I showed you of Alvarado, where the central space is a connector. So normally it's a living area, family room, where all the spaces derive from, and this creates a very centralized area, we normally call it homey layout. In terms of height, the way height affects the dwelling design is by literally increasing the facade surface, but also creating a higher hierarchy of how the functional zones are connected to each other. Double height, not double height, two-story dwelling units or duplex units allow for a very hierarchic separation of areas between living areas or private areas, public, private, living, sleeping. Different people like to call it in different ways, which is a plus. If you need to have that hierarchy on the design, it allows for a duplication of the facade surface, but in height, not necessarily in width, because sometimes we don't have the width to play with, and it allows for deeper units, as I explained to you previously with the example of the unité d'habitation. Triplex units obviously optimize the facade surface the same way that the duplex units, but might create a serious problem in terms of circulation. How do you distribute units in a triplex dwelling? What do you put on the ground, on the first, on the second? How much are you going to make people go up and down staircases are considerations that have to be very well thought of before making one of these decisions. For example, in this case, the Nexus World by OMA have a very interesting configuration where the living room is in the top of the unit. Normally, in a duplex or triplex unit, you have the ground floor for living areas, and then, or sometimes garage, and then living areas, and then bedroom. So as you go up, you become more private. But what happens when Ramkulis was designing the building is, okay, we enter through an area that has a courtyard and should have, you know, that area for laundry, storing your bicycles, maybe making a barbecue. It's kind of a service zone, but it all has to be an entrance zone. But in reality, it's an area that we don't have to go much unless we are doing some outside work or we are going out. Then the majority of the activities are between the first and the second floor. But if he made the living rooms, or according to him, if he made the living areas on the first floor, then the access to a terrace and to natural light will, and the exposure to noise would be actually lower than in the bedrooms. And for him, that wouldn't make much sense. So he preferred to locate the bedrooms in the intermediary floor, that is the first, so that on the top floor you would have a wider terrace with the living areas, kitchen, living, and so normally as you enter the house you go straight up, and then at the end of the day you move to the middle floor. Case it's important that you think how much people will have to go up and down the staircases, because it can be extremely tiring, and of course for a certain age group it might be completely normal, but when we are talking about children and elderly, it starts to create a problem. Then besides, the height can be stacked vertically normally, but it can also be stacked in other ways. Normally, there are three main ways of doing this stacking of units on top of each other. There is the typical duplex, triplex, and so on. Then there is the split levels. That is one that I particularly am very fan of. That is when you break the units into half floors. What does this do? It's better to look at the example to understand it. This is the Diagon Housing Project by Erzberger. What this does is to create a higher relationship between floors, because on one floor you are always seeing half of the other floor, and so on and so forth. While when you are in a typical duplex, if I go to the bedroom area, I get completely disconnected from the living area. Yeah, I can have voids and so on, but voids also occupied space. In a split level, or what we call half floors, what happens, you might have a very small void connecting all the floors, but because you are only 1 meter, more or less 1 meter above the previous floor, you have a wider visual connection with the rest of the house. So if you want to create a middle term between the connectiveness that a single unit, a simplex has, And the privacy or the higher hierarchy that a duplex has, I guess the split level is the best middle term in between, because it gives you a higher degree of privacy and separation, but still maintaining an acceptable degree of visual connection. Then we have diagonal stacking. The main advantage of the diagonal stacking, like we see in the mountain dwelling, is the ability to create terraces over the roof of the previous floor, which in some designs are very important. And so instead of me having balconies that step out of the building, I have almost like recessed terraces that are more private and allow for a wider range of functions to take place. And then we have the, oh, this is the example of, sorry, the diagonal stacking still. And then we have the complex stacking. Complex stacking, it's something that I think is a type of stacking that all architects just love to explore, because it's like playing with Legos, but you have to be very careful with it. The only advantage of a complex stacking is when your design concept is based on the idea of having variety. So imagine that your design is about creating a considerable amount of variation in terms of dwelling units design, to make sure that, you know, different people with different tastes will always find something that almost looks like it's personalized. So this idea of personalization and variation is what you achieve with the complex stacking. Not only it gives you variation, but also a sense of almost uniqueness. And it's very interesting, but it's also very difficult to do. This is an example of the LMV houses by Bjarke Ingels. I mean, I guess I don't have to go further for you to see or how complicated overall it is to put all these things together, because you are still stacking units in a building that have to have common circulation cores, common shafts to make the mechanical ventilation and the water supply and the water drainage. So it's a complicated task, but it's very interesting, like I said, when our design purpose is to create variation. And these are just, I wanted to give you some examples of the units and how the plans work, because it's something that honestly all students in Design 5, normally not all students, some students want to explore, and I always like or try my best to be very real about the struggles that you are going to face. I am not telling you in any way not to be brave and try, but I think it's very important that for each choice that you make, perfectly aware of what is the struggles that you are going to face, and then deal with them. What is bad is when we don't know what we are going to face, and then we get surprised in the middle. No, I think you should be creative and do all sorts of experiments, but it's very important that we know, you know, what are the problems, because if we know the problems, we know how to deal with them. And this is another example of the units, how they work. It is very interesting to think, you know, that you can have a building, for example, in this case, it's a triplex that you go up and down. So it's a very similar situation like OMA or Ramkulus was saying in this Nexus world. That is, if I enter in the center, right, and then I have a stair that goes down to the bedroom area, and then I have another stair that goes up into a mezzanine floor that is a working area. In reality, I have a triplex, but I am not going up and down the stairs a lot, because in reality, I move mainly between here and here, that is the bedroom and the living area, or between my workplace and the living area, or if this is not a workplace, if it's another bedroom, between the bedroom and the living area. So you can have triplexes that actually work like duplexes if you locate the functions properly. Another advantage of a complex stacking is, as you can see here, I have a combination of double-oriented units that actually face different, sorry, not double-oriented, single-oriented units, but that are oriented to different sides, which sometimes is an advantage when we want to take the maximum advantage of the sun. This is what complex stacking does to you. It's this ability. I will just go back to this example. So here is the same. See, I enter through the red one. I enter through this area that has a kitchen and a work area, and then I can go down to an area that has, so it's a single oriented unit and then a double oriented unit. It gives you a sense of variety that I think it's important sometimes in the design. It depends on our concept. Okay, so this is our lecture for today. This is the study references that is available. It was available on Edmodo, and now it's available as well on Blackboard. If you want to grab more information about it. Um, Next week, we will discuss how these units now are grouped together. I mean, you already see how they can make a building, but next week we are going to discuss how these units then are grouped together to form different types of building forms. That is what we call the assembly of the residential building. So thank you so much for watching. I hope it was of help. If you have any comments or suggestions, please write it down on the chat or send it to me. It's always very useful. Thank you and see you next week.